Graphing sine of x. So we've done trigonometric functions and we know the sine of an angle gives us the ratio of the sides. And we worked with sine of x in the unit circle, noting that in a unit circle it's the y coordinate. Well, what if we took a moment and we tried to graph it to see if it was a function? So we let y, or f of x, equal sine of x. So to find the sine of x, we can actually use our unit circle to find different values, different ratios of sides. We know at 0, sine of x is also 0. So we can plot that on our point, on our graph. And now we can graph angle measures, the input of angle measures, and the output gives us those ratios of the sides. So for example, if we have pi over 4, we've done this where we made this a right triangle. This is a 45-degree triangle. We know this radius is 1 and the sine is the opposite over the hypotenuse. So that's where we get our square root, 1 over square root of 2, which rationalizes to square root of 2 over 2. So we can find the sine of pi over fourths, which is, or pi fourths, which is just square root of 2 over 2. And we can plot that. Now square root of 2 over 2 is approximately 0.7. So this is the ratio of my sides, that's my output, and it's approximately 0.7. So at pi over 4, I'm about at 0.7 if this is 1 up here. So then I'm going to erase this triangle so we can look at it. So essentially, the sine of my angle in my unit circle will be the height, or the y value. So as I was over here, like if I were at pi over 6, I know that that's 1/2 or 0.5. So that's a little bit less down here. So if I were to plot pi over 6, I would plot 0.5 about right here. Okay, but I didn't do that on this one just to make it easier for you to see. Then I could go on and plot pi over 3. Pi over 3 is rad 3 over 2, which is again going to give me a little bit more closer to 1. So it's a little less than 1. Then if I go on to pi over 2, when I put in pi over 2, I look at my height, and my height, or my y value, is 1. So I'm going to get up here to 1. Now what happens to my height is I continue around that circle. It's going down. So it continues to go down as I go to 2 pi over 3 and then to 3 pi over 4, which I actually plotted. At 3 pi over 4, I'm at rad 2 over 2 again. So I've gone from 1 back down to about 0.7, which is about right here. And then I can go down from there. I go here, so my height here is about 0.7. My height at pi is 0, so I haven't gone up or down in any direction. So I go ahead and plot a 0 there. And I can see it's kind of giving me this wavy curve. And I can plot those values in between of pi, of my thirds and my sixths as well, to get a little bit better idea of what's happening here. So then, after I go to 0, I go over here to this part of my unit circle. Now notice my y coordinate is going to be negative. It's going to be negative rad 2 over 2, or about negative 0.7. So I can go ahead and plot that down here. When I get to 3 pi over 2, my height, right here in the red, is going to be negative 1. So I'm down here at negative 1. Now that's the lowest I'm going to go, because you can see my height changes and it goes back up again. And then I have negative rad 2 over 2, or negative 0.7. And then at 2 pi, I'm back here at height 0. So 2 pi, I'm back here at height 0. And then if I continue to go around, I'm the same height I was at pi over 4. So I'm back here at 0.7 if I have 9 pi over 4. So this is 8 pi over 4, 9 pi over 4. I'm right back up here again to square root of 2 over 2, or just 0.7. At 5 pi over 2, I'm back up to 1. And this is just going to continue as I go around the circle. Let's look at what happens if I do negative values. So if I did a negative pi over 4, I would go this direction, pi over 4. If I did, my height would be negative rad 2 over 2, or negative, about negative 0.7. Same thing with negative pi over 2, I'm over here at negative 1. At negative 3 pi over 4, I'm back over here, still negative, at negative rad 2 over 2. And when I go negative pi, I'm back at 0 over here. So I have no height. I'm not going up or down. So the sine of x is actually measuring my height as I take that ratio of the angle. So when I put this all together, it makes a periodic function. Let's see if I can connect it nicely. It's harder to do on camera than if I just had it flat. So up and then back down. Oops. And then down and back up again. And it's just going to continue on and on as we go around that circle. That height's going to continue to go up to 1, back down to 0, down to -1, back up to 0, up to 1 again, and back down. It's going to continue to do that in both directions. And so now I have a new kind of graph. It's a periodic graph because it repeats after a certain period of time. And so I can see that after I've gone 2 pi, either from -pi to pi or from 0 to 2 pi, it starts repeating again. So this is the graph of f of x is equal to sine of x. We could also say y is equal to sine of x if we let this be the y-axis and this be the x-axis. The x-axis measures angles, so these are all angles. And up here measures the height, which is just the ratio of the sides because the hypotenuse is 1.